Today's lesson is on finding the greatest common factor. Let's review what these words mean. A factor is a number that is multiplied by another number. For example, 3 times 2 equals 6. 3 and 2 are the factors. 6 is the product. Another word we're going to review is greatest. Greatest means the largest. And the third word is common. Common means it happens many times or more than once. So when we put all of these together, we have the greatest common factor. So we're looking for factors that occur more than one time, and we want the largest of those factors. The greatest common factor of two numbers is the largest factor shared by both. You can determine the GCF by calculating all the factors of both numbers and finding the largest one. So for example, we wanted to find the greatest common factor of 12 and 10. One way you can do this I call the ladder method. This is where we list all of the factors, circle the common ones, and then take the largest one we see. So let's start with 12. We know that every number has 1 as its factor. So we're going to start with 1 times 12, which equals 12. The next logical number to go to would be 2. 2 times what is 12? And that's 2 times 6. And notice 3 would be next. 3 times what is 12? 3 times 4. And if we go to 4, we know that 4 times 3 is 12. Now this is a reverse of 3 times 4, which tells me I'm done. I can draw a line between the two reversed factors, and I know that I have all of the factors of 12. Let's try 10. We know 1 times 10. We know that 2 is a factor of 10 because 2 times 5 is 10. 3, does 3 go into 10? Not equally, so we're just going to put a line through that. 4 is not a factor of 10, but 5 is a factor of 10. 5 times 2. Notice it's the reverse of 2 times 5. So you can draw a line underneath the reverse, and you have all of your factors. We're going to look at the numbers above these lines. We're going to circle all of the common ones. Common means they show up in both the numbers. So we have 1s, we have 2s, no 3s, no 4s, no 6s, no 12s. So remember, when you go and look at all the factors, you have to go all the way around in a U-shaped form. Now, the greatest common factor of 2 and 10 is going to be the largest factor that we circled, and in this case, it is 2. Let's try one more. Find the greatest common factor using the ladder method. So we have 24. 1 times 24, 2 times 12, 3 times 8, try 4, yes, times 6. How about 5? Well, 5 doesn't work, so we just cross it out. What about 6? 6 times 4, there's my reverse, so I just draw a line, and everything above the line are the factors for 24. Let's do 36. 1 times 36, 2 times, and if you're not sure, do it on the side. I know 2 has to go into it because my rules of divisibility says it ends in a 6, and that's an even number. So 2 times 18. Again, you can do 3 to the side if you need to, and you will have to list them. So don't miss any. 3 does go in. I know that 6 plus 3 is 9, and so therefore 3 is a factor. 4 times 9. 5 times, well, 5 doesn't work because it doesn't end in a 0 or a 5. And then we have 6 times 6. Now this one's a little unusual. We aren't going to be seeing any reverse of the factors. So all we have to do is notice that this is a double right here, 6 times 6. So therefore we are done. All right, let's circle our common factors. 1 is common, 2 is common, 3 is in both of them, 4 is in both of them, 6 is in both, and it doesn't really matter which 6. No 8 over there. How about a 12 in both of them, though? And no 24. So we can say the greatest common factor, or GCF, is 12. You go ahead and try to find the greatest common factor for 18 and 24. Pause the video now, and then return to find another way to find common factors. A second way to find common factors, greatest common factors, is using the prime factorization. And we'll use factor trees for that. Remember, our factor trees break down the number into prime factorization, only prime numbers. So here's the example of 36 and 54. We know that the factorization, prime factorization of 36 is 2 times 2 times 3 times 3. And for 54, 2 times 3 times 3 times 3. First thing we need to do is find what they have in common. I see we have a pair of 2's, a pair of 3's, and another pair of 3's. To find the greatest common factor, all we have to do is take and multiply those sets of numbers together. Now we're not multiplying 2 times 2, we're just multiplying the set of 2. So we just take one of the 2's and we multiply it, and then we take one of those sets of 3 and one of those sets of 3. So 2 times 3 times 3 equals 18. And we know that because 2 times 3 is 6, and 6 times 3 is 18. So the greatest common factor of 36 and 54 is 18. Let's practice one. 45 and 15. 45 ends in a 5, so I know I can break it down into 9 times 5. 9 is not prime, so I break that down into 3 times 3 and bring that 5 down. There's my prime factorization for 45. 15 is just 5 times 3, or 3 times 5. So let's write it out. 15, 3 times 5. 45, 3 times 3 times 5. Let's find our pairs, or factors that are in common. 5's, and they don't have to be on top of each other just to match. It just has to be one from the top, from the first one, and one from the second one. So the greatest common factor is going to be 3 times 5, which equals 15. And I do know that 15 times 3 equals 45. You go ahead and try this. This one is finding the greatest common factor of 32 and 60. Pause the video, try it out, and then I'll give you the answer when you come back. All right, so for 32, we have 8 times 4. 8 can break down into 2 times 4, and 4 can break down into 2 times 2. I see that 4 is not prime, so I'm going to break that down and bring all those other 2's down. 60, that's easy, 6 times 10. 6 can break down into 3 times 2, and 10 can break down into 2 times 5. Now let's find our matching numbers. Let me write it out first. 1, 2, 3, 4. There were 5 2's in 32. And 60. 1, 2, and then a 3 and a 5. So if I find my pairs, I have a 2 and a 2. So it looks like the greatest common factor is 2 times 2, which equals 4. Here are 2 more examples for you to try on your own. Try them both ways and see if you get 2 answers. These are the ones that we will be looking at in your notes when you come and return to class. Good luck!